Okay. Think I have it all. Hopefully we don't hit any snags. I'll try and keep my eye on this. Yeah, I know. All right. So, a couple announcements here. Let's get back over here. So I don't have it actually written in the thing here, but I'll talk about it just for a moment. Just kind of some like organizational stuff. So last things got a little goofy. I had that crash happen in the middle of class and I had to hop off and hop back on. So, and in doing so, apparently my screen capture did not capture. So I lost that whole part of that lecture. So I'm going to be re-recording that. And as a result, I couldn't get the homeworks posted yet. So I am going to try and get that re-recorded, at least, excuse me, the first half of it re-recorded this afternoon, and then get that posted. And then alongside of that, I will also get homework 2 posted. So the rule is whenever I do homeworks in this class, I always give you at least 1 week. So if, like in this case, something gets delayed for homework 2, you'll always get a week to do it. So it's not like I won't post it like tonight or tomorrow and have it due on Thursday. So you'll always have at least a week after the content is posted that to do it. So it may happen that like some stuff will get backed up and bunched up a little bit, but in terms of like when I post it to when you have to do it, you will always have a week. And I'll try to make that very clear. I realize, that it can be kind of complicated in keeping track of what's due when, especially when you have lots of different classes. So my best suggestion would be, of course, look at the calendar and the syllabus section in Canvas, and that'll really help. I'll kick out stuff in terms of announcements to try and keep that clear. But, in case you missed the announcement or something like that, keep an eye on your calendar and on your syllabus inside of Canvas, and that should really help kind of keep things organized a little bit. So what we're going to do this week. Oh, yeah, go ahead. Hell yeah. Thanks for the reminder. We'll get a lot more of that in there. Well, you're going to be hearing a lot of that this semester, by the way. So you're in luck. So, cause I don't have, yeah, I don't have normally when I do this in person, I'll have you guys do it, but it makes it kind of tough with the mechanics of this system. So, cause I'm like, yeah, I just use that. The voice is the low hanging fruit, but it's also one of the most interesting things. As a bonus, you get to hear my awesomeness. So, I don't know. Has anybody read the Expeditionary Force series? It's an audiobook on Audible. Anyway, it's this whole AI. They call him the beer can. His name is Skippy, and he sings a lot, and he's terrible. And so I try to be like him. He's super arrogant and really bad singer. So I will try to play that part, even though I try to not. At least I don't like to think I'm that arrogant. I'm actually a terrible singer. So I'm self-admitted about that, and I'd be willing to bet that everybody in this class can sing better than I. I already know that you all have better theory than I do, so I'm sure you can sing better than I can. So I will just play the fool, and you just have to deal with it. So, all right, cool. So what we're going to do starting this week, so last week we ended up finishing up chapter 1, and now things are going to start picking up a little bit, and we're going to start really chipping away at kind of some of the content in the book, and we're going to be essentially kind of going on I think about a chapter per week. So if you haven't read it with this one right here, it's like they try to attack this concept early in the book, like in terms of like the information that we want to deal with, but this is complicated stuff. So this is going to be, we're going to talk about decibels, and decibels is one of the most vexing things in our industry. We throw around decibels all the time as if it's like, add 6 dB here, add 10 dB here. Oh, can you cut 3 dB at 500 hertz there? And people oftentimes really have no idea what a decibel means. And myself included, for many years, I've worked in this industry most of my life. And for a good chunk of my career, I didn't really have a good grip of, I knew what a decibel was like on the fader a little bit, but I didn't really know what it meant. And even if you look at your faders, like say in either on an analog desk or in Ableton or Pro Tools or any of those kind of things, and you actually look at the numbers of what they're going on there, you're like, it goes from 0 to negative infinity. That seems strange. Like that just, the numbers actually never really added up. And I just kind of just dealt with it like everybody else in the industry. But it's amazing once you start to getting a grip of understanding what a decibel really is, how it plays into our industry. And at the back of the book, they give a bunch of example calculations, which I think are incredibly difficult to take in the first time you look at this. So what we're going to try to do in this section of the book, and just this section of our career and understanding, is just to get through this enough that we kind of have a good concept. I used to really hit this stuff hard, and people like were mad at me and bored with it, and I don't know. I think it's fascinating but it does require a fair amount of math. So with that said, get your calculators out, because we are going to be doing a fair amount of that today. But I think that once you kind of work through the mechanics a few times and you get the hang of it and you just understand the core concepts, that's all we really care about. Going through and doing the hardcore calculations of things like distance and inverse square law and all this stuff, it's important. And especially if you're designing, say, an outdoor sound system for 10,000 people, you need to know how big of amps you need, how much SPL is going to be hitting the people at different stages in there, or how much amplifier is going to have gain, or how much gain you need to add to a microphone for a mic preamp, and there's all these reasons to use decibels for all these different things. But we're going to kind of confine it and keep it fairly narrow, just because, well, I don't want to spend half the semesters on decibels. I think it's fascinating stuff, but we'll keep it kind of like keep it pretty mellow. So let's start off on this thing. We're gonna take the slow on ramp with this idea of decibels. And so I'm gonna before we jump into decibels, we want to talk about these just relationships with the numbers, and then that will build into our understanding of what a decibel really is. So if you've not read it, like I would recommend you read the chapter, and then well, I mean, if you've read the chapter, you probably go, holy crap, this is a lot of like math. And there is some math here, but don't worry, we got you. We're gonna take the slow on ramp, like I said, and we're gonna work this. Thing I will say today is we are doing clickers today. So today's the first day that we're actually gonna put clickers to work. So get those clickers out, the app pulled up and ready to go, because we'll get to it when we get to the first question. And we'll work through it together, because there's always a few stumbles, there's always a few hangups and a few snags. But as I'm talking here, if you've not downloaded the app, the iClicker app, download the iClicker app and get signed up. Like, find this course. The easiest way to find this course is to look for my last name. Like, you'll find University of Colorado Denver, and then you look under Merkel. Don't search for the class and all that kind of stuff. Just search by instructor name and look up Merkel, and you'll find it. It's a lot easier that way. So, and like I said, I know there'll be some snags and there'll be some hangups here, but Carter, if you can kind of help mitigate some of that along the way, but we can address it as a class as we get to that, as we get up to those. All right, buckle up, my friends. Also, so in terms of one thing about the calculator, I will make a quick note on the calculator here. So you can use your phone as a calculator, or if you're on your computer, obviously you're on your computer right now, unless you happen to be on a mobile device, that you can use the calculator, but it's kind of hard to switch them back and forth between using the calculator on your phone and the iClicker app. So I would recommend using the calculator on your computer if that's what you're watching on right now. Okay, let's do this. Let's talk about this thing here. Let's just do a little quick discussion here. Let's talk about what a ratio is. So when we talk about a ratio, we talk about something like 50 to 1. So it's a ratio of, we have 50 of one thing and we have 1 of another thing. So that's like a ratio. So in this case, if we had something like this, in this case, if we started with 10 and the other value is 500, I could say that's a 1 to 500, or I could say that's a 500, I'm sorry, 10 to 500 or 500 to 10 ratio. But they can also, because of this, it's a ratio, we can also like reduce that down to 50 to 1. I could leave this as a 50 to 10 ratio in the same way that I could say I have a 4 to 2 ratio, right? So a 4 to 2 ratio is the same thing as a 2 to 1 ratio. Oh, sorry, let's say, 4 to 2 ratio is the same as a 2 to 1 ratio. So they can be reduced. So basically, the colons here, when we talk about that in terms of that implies this idea of a ratio. So a ratio is a comparison. So let's just define that for a minute here. So a ratio is a comparison of magnitude. So it's a comparison of how much of one thing to how much of another thing. But it's kind of like an equal symbol. It's like it has this kind of property where I can apply some math to this thing a little bit. So in the case of this one, if I say I have something like 50 to 1, that means it's a proportionality. It's a ratio. So if I have so I can have 500 to 10, or 5,000 to 100, or 50 to 1. Those are all the same ratios. So in the same way, when I was saying a 2-to-1 ratio is I have 2 of one thing and 1 of another. The same thing as if I have 4 of one thing and 2 of the other, or if I have 6 of one thing and 3 to the other. Those are all 2-to-1 ratios. And again, you can kind of treat those like an equation, like a math thing, where I can divide by the lowest common denominator between the two of these. They don't have to be whole numbers. It could be 50.3 to 1 if it turns out to be that case. But in this case, I'm using a very clean number. But we could also do something like this. Like if I started with 20 and the other value is 1,000, then if I'm comparing 20 to 1,000, that's also a 50-to-1 ratio or a 1 to 50 ratio. So basically what we're doing in the case, if I have a 20 to 1,000, if I divide this by 20 and divide this by 20, I get 1 to 50. So this idea between ratios is kind of important, is just this comparison. And I think that's what I want you to, that's what I kind of want to burn into your brain right now, is this notion that ratios are comparisons. It's a comparison of magnitudes, to be a little more technical, but it's a comparing two different things here. It's a comparing the amount. When I say magnitude, it means the amount. So it's a comparing of this to this. But the interesting thing with this is that they're dimensionless. So let's use an example here. Say I have 2 apples in this hand and 4 apples in this hand. What's my ratio? Well, it turns out it's not 4 to 2 apples. It's just 4 to 2. Because effectively, in like equation speak, we can the apples cancel each other out. So the apples cancel each other out. And so it's just a 4 to 2 ratio. So it's not 4 to 2 apples, it's 4 to 2. So this is an important concept that we'll build upon. But when we do a comparison, a ratio, they're actually dimensionless, because the dimensions, when I say dimensions, in this case, the dimensions are apples. But it could be 5 meters to 500 meters. So if I did 5 meters to 500 meters, it comes out to 1 to 100. Not to 100 meters, just 1 to 100. Because it's on both sides of the equation, so to speak, that they cancel each other out. And so comparisons, ratios are dimensionless. And that's kind of a funky thing to think about, but basically they cancel each other out. So the term is dimensionless. There's no dimension to this. It's a comparison. It's a 2 to 1, 4 to 1 ratio or something like that. Like it's a ratio, it's a comparison, but there is no dimension associated with this. Cool. What do you think? Does that make sense? We good? Sorry, I'm trying to keep my eye on the chat, but it flies by and it's on my other screen right here. So I'm going to be missing a lot of stuff, and I'm counting on Carter to kind of fill in those answers if you have it. And you guys can of course answer amongst each other, but okay, cool. But you guys are welcome to hop on the mic when I'm asking for it, anytime too. We good? So I'll give you a minute, but if silence at this point means let's move on. So anybody else got some tips? It's I click. Oh yeah, go ahead. Yeah, it's a little triangle looking thing. Is that what it is? Mm-hmm. Or just, yeah, see if you can try Smith just to see if you can get a list to see if it's populating correctly, just to make sure that it's actually syncing. Okay. And when you're looking up those other instructors and you click on it, does it show what like normal class like names like CSCI or MUSC, or like does it show the courses that they're teaching? I just want to make sure that it's like seeing. So I would cancel out, like double click and cancel all the way out of it, open it back up again, and see, like, just see if you can force it to refresh. Um, yeah, yeah. I would just can't kill the app and open it back up and make sure it's like forced resyncing it kind of thing. Mm. So try doing it from the browser on your computer and see if you can do it. And that goes for everybody else too. So you don't need to use this strictly on your phone. You can also use the browser, use it in the browser, and see if you can get that to like sync up with your system that way as well. Try it there, and then go back to your phone and see if like those two will sync up with one another. So tell you what, like let's hammer on that. Well, let's move on, and when we get to the actual questions that are coming up here, then we'll address that, and we can kind of hammer down with that, because it sounds like it's a isolated case. So but I do want to address it. I don't want to move. I don't want to leave you leave you behind, but I do want to kind of get things moving here, just so we can get things going. But we will address it as we get to those questions. Cool. All right. Okay, so let's do this. So this, like, I'm gonna sidestep this concept of ratios for just a moment. So we have this like ratios, these comparisons. So now we want to do this, and let's apply it to like a perceptual experiment. And so like, how does this compare? Why are we even talking about this? Well, it turns out in when we say like, if we do this with sound, we'll start with sound. This concept of sound, and what we're gonna do is play a given intensity. So intensity is the physical description of intensity is force per square, for force per area. So it's how much force is in a given area is the intensity. Or that's pressure actually. So intensity is per time, I think, as well. So but basically we'll come back to that, the definition of what intensity is, but we'll say that intensity is a physical value of the amount of energy being propagated through the air. And in this case, it's like what is hitting our ears. What's the intensity of the sound hitting in our ears? So if we were to go up and play a sound with a given intensity, and we say that we'll just give it we'll just give it an arbitrary value of 1. And what we want to do is we want to turn it up and to ask the listener to say, how long is it going to be until like let's say, click in when you think it's going to be twice as loud. Well, it turns out it's pretty strange that when you keep turning this thing up, it takes 10 times the intensity to feel twice as loud. So there's a mismatch here. So it takes 10 times the intensity to sound twice as loud. So we see that there's this weird kind of this mismatch in perception versus physical, what's going on there. And what's strange about this is that if I were to say start at 10, And so if I started a layer of 10, I go, okay, so if I start at 10 and I want you to say, how loud is it how loud is it? I'm going to turn it up and I want you to click in when you think it's twice as loud. Well, it turns out it goes from 10 to 100. So that means for every single time I want it to feel twice as loud, I have to go 10 times the intensity. So this is kind of strange. It's basically, and if I go, yeah, so again, starting at 100 intensity and increasing until it sounds twice as loud, I'd have to go all the way up to 1,000 for it to sound twice as loud. So what we see is that it takes about 10x for every single time for this thing for you to sound twice as loud. And we can see that that's kind of on an exponential scale right there. And it turns out that most of our perception works on this compressed system. So in other words, we're really sensitive at low levels, but we're really insensitive at higher levels because it compresses our senses. So it allows us to have a very, very, very broad range of sensory input. And this is true for our eyes with the way we perceive light. And I don't know what the scale for light is exactly, but light is the same way. So if I were to say, turn on, you can try this yourself. This is a pretty fun experiment. So if you have, let's say, a lamp and you have two lamps. So if you happen to have two identical lamps in a room, turn off all the lights and turn on one lamp. And just have one lamp turned on in a dark room. And if I turn on that second lamp, ask yourself, does it look twice as bright? And the answer is no. Because when I have one lamp on and I turn on a second lamp, it looks just a little bit brighter. So in this case, if it correlates, and I don't remember how our eyes work exactly, but if it correlates the way hearing waves, it would take 10 lights to look twice as bright in the room. So this is a kind of another one. Same thing if I push on something. If I have my sense of touch works in a similar fashion. So I've got my little Apple Pencil right here. And if I were to touch my hand right here and I measure the amount of force that I have in my hand right here, if I double that amount it takes 10 times the amount of force to feel like it's pushing twice as hard. So this is and this is not just something of the humans. This is across the animal kingdom that our senses tend to work on a logarithmic scale. And the reason being is, again, it allows us to it gives us an incredible range of sensory input so that we can see that when it's really low levels, we have really good sensitivity in between those. And when it's really loud, we have pretty good sensitivity. Well, I mean, moderate sensitivity at the louder levels or the louder intensities. So this is kind of an interesting perception. So the challenge is, and this is why it's weird. This is why we don't use intensity or we don't use raw intensity to describe sound, because the scale is so incredibly off compared to the way we hear things. So it turns out we need a different way to describe how we hear loudness. And so that's why we use this. That's where the decibel comes in. So let's look at the difference versus ratio here. So the difference in a first set is 9. So, well, I don't know. This is a little vague. The difference in the second set is 90. So, okay. So in this case, what I'm doing here is I'm looking at the difference. So if my ratio is 10 to 1. So the difference between 10 to 1 is 9. And the difference between 10 and 100 is 90. And the difference between, so if we were looking at this, so like a ratio would be 10 to 1. This is a 10 to 1 ratio. This is a 10 to 1 ratio. So if I was looking at this one value and this one, at the ratio between these two values here, that's a ratio of 10 to 1. This is a ratio of 10 to 1. This is a ratio of 10 to 1. But the difference is 9 to 90 to 900 right here. So the ratio in each of these is 10 to 1. But the difference is changing. So turns out the ratio is a much better way for us to consider how we describe it. So what we can say is that each time there's a tenfold change to feel like it's doubling. So when I say tenfold, it means a 10 to 1 ratio. So that term, when we say fold, it's kind of a weird word, a weird word to describe it. But when we say something's 100-fold, it means it's 100 times the original value, or it's a ratio of 100 to 1. So a tenfold. So like a tenfold is a 10 to 1 ratio. So that means if I start at 2, so let's do a couple ones. So we're keeping it simple right now, but it's 10 to 1. So if I start with a value of 1, it goes to 10. If I start with a 10, it goes to 100. If I start with 100, it goes to 1,000. But what if I start with something like 2? Well, then it goes to 20. And 20 goes to 200, and 200 goes to 400. So 200 to 20 is a 10 to 1 ratio. So that'll become a little bit more clear as we move along here. But I just kind of want to, I don't like, they talk about this difference versus ratio in the book, but to me, I think that makes things more confusing. But it's just to highlight the differences, that these are all 10 to 1 ratios, but the difference is, you can see, is growing, in fact, by a factor of 10 in each of these. So that kind of correlates back to that 10 to 1 ratio thing. Okay, so let's talk about this perception. So most of our senses, vision, touch, vibration, electric shock, are ratio based. So we use ratios or as part of our sense, as our senses. So it's like a 10 to 1 ratio is a doubling of our sensation. So ratios of stimuli come closer to matching human perception than do absolute differences of stimuli. So that's why we're talking about that differences, is because the difference, we don't really feel the difference. We feel the ratios. We perceive ratios between the differences of these. So pretty cool stuff. I mean, and I think I was just listening to, what was I just watching? I don't know. I was just watching some show, and I think they were even talking about this on like NPR the other day, on how our perception works. And this is an important concept. So, this is like maybe a little trivia for the day, is like understanding how these ratios work. Okay, so now what we need to do is we need to get into a little bit of the math, because what we're trying to do is develop this notion of ratios, but now we need to start adding some numbers into this thing. The thing is, when we start talking about perception and how we perceive like physical phenomena, the range in which we can perceive the quietest sound to the loudest sound is intense. Well, intense is the wrong word, is insanely big. So we're working with really big and really, really small numbers. And so to do this, we need to kind of get comfortable with this notion of how we express these very large and very small numbers. Because when we start, again, talk about the range, like it's just massive, the scale in which we can hear stuff. So let's look at this. We want to take a look at this. This is pulled directly from the book, and we can write stuff in decimal form here. So right here, if we start at 100,000 and we drop down and we go all the way to 0.0001. So that's like the decimal form of writing this thing. But we can write that as, this is 10 times 10 times 10. And this is the very simple, we're simplifying this for right now. But this case, 100,000 is 10 times 10 times 10 times 10 times 10. So it's 1, 2, 3, 4, 5. So there's 5 tens multiplied towards each other. So if we write this in exponential form, we could say 10 to the 5th. So if I write this, in fact, I want you to do this right now. Get your calculator out. I'm going to do mine. Let's get my calculator. I'm going to switch to my calculator for a second. There to go. So I have my calculator right here. And for my case, like, you might want to switch it to the view to scientific. So you can do program or basic, because if we do basic, it's not going to have all the buttons we need. If you want to switch it to scientific, you can switch it here. If you're working on your phone, that if you turn your phone sideways, it will, calculator apps turn to scientific mode when you turn them sideways. If you're in portrait mode, it's going to be basic. And if you turn it to landscape mode, it's going to turn to scientific calculator. Maybe if you have a different app, you may have to go ask it to turn into scientific. So we see that we have this button right here called 10 to the x. So it's an exponential one right here. So if I hit 5 and hit 10 to the x, sure enough, I see that it becomes 10 to the 5th is 100,000, just like as we saw in here. I wish I could keep my screen pulled up, but I can't keep my presentation and my screen pulled up at the same time. But let me go back to that for a moment. Let's go back to Keynote for a sec. And if I do this right here, so if I do 10 to the 4th, what I want you to do is type 4 10 to the x. And what you'll get is, you get 10,000. So this is a way we can write the exponential. So what we say here, and kind of if I want to kind of do a shorthand notation of this, is we could say how many zeros are after this first one. So if we look at this, there's 5 here. I go 1, 2, 3, 4, 5. So there's 5 zeros. In this case, there's 4 zeros. In this case, there's 2 zeros, 1 zero. There's 0 zeros. In this case, they can say how many decibels, or we can also say how many many decimal points, or how many places does the decimal need to move? So this is going to go 1, 2, 3, 4. Oh, sorry, 1, 2, 3, 4, 5 to get to this value right here. And then in this case, I'm going to go like on the 10, it's going to go 1. On this 1, it's going to go 0. But on this one right here, if I want to get that 1 by itself, I have to go this direction. So I go -1. So I could say this is 1/10 or -1 here. So it's basically, it's reversing the direction. So this is how I think about it. You may have come up and maybe in your old math, or maybe that you have kind of your own shorthand way of thinking about it, but maybe this is new to you and you haven't seen it for a long time. But it's how we move the decimal points around to isolate the most significant figure right here. So in this case, I'm going to move it to the right. And when I do move to the right, it moves in the negative direction. 1, 2. So it's a -2, -1, 2, 3, -3, and -1, 2, 3, and 4. So it's -4. This is a little more complicated. It works, but it's a little more kind of complicated to think about here. So in this case, we see the same thing we had here. We could also take this as 100. So 100 is 10 to the 2, and 1,000 is 10 to the 3. And I can actually add the exponents. I'm not going to spend too much time worrying about this right now. These are just kind of some arithmetic rules. I'm going to skip this part right now. This will come a little bit clearer as we move along. But I just kind of want to like start with this idea right here, because what we want to do is build up this notion of scientific notation. So scientific notation and exponential are used to express very large and very small values in a condensed format. So insignificant values get disregarded. So the exponential value tells you how many decimal points to move to make it so you have a single digit in front of the decimal point. So in this case, I'm running m times 10 to the n. So what we're going to do here is we're going to say this is like basically like this is going to be our significant value right here, and this tells us how many decimal points or how many zeros, decimal points zeros this needs to move around. So let's do some examples here. So let's talk about like a decimal notation, and we'll do a scientific notation version of this thing. So in this case, if I take 1,000, if I want to write 1,000 as scientific notation, what I'm going to do is I'm going to take this, I'm going to go, okay, it's 1, 2, 3. So that I isolate this value right here. It's going to be 1 times 10 to the third. So I get 1.0, because this is 0 right here, times 10 to the third. So what that tells me is that these values are the two of the same thing right here. Let's do another one. So let's do one that's not just using ones. So let's represent 300,000 in terms of scientific notation. So in this case, what I'm going to do is I need to go move this over 1, 2, 3, 4, 5. So it's going to end up with 5. So it's 10 to the 5th. So this bit is the 10 to the 5th, and this bit is the m that I showed in the other one. So it's going to be 3 times 10 to the 5th. So before we move on, let's do this. I'm going to go to my calculator, and let's talk about how we actually type this out on our calculator right here. So let me clear that out. So if I want to write scientific notation, there may be like if I was writing 3 times 10 to the 5th, this is the wrong way to do it. I would write 3 times 10 to the 5th. Oops, that's not right. There's this one right here. It's the EE. This one right here is the scientific notation, exponential notation. So what we do is we go 3 EE 5th. So that's 300,000. So this is something I want you to do that on your own. Try that out for me real quick. So go 3 EE 5 and then hit equals. So 3 EE 5 is 3 times 10 to the 5th. That's what that's saying. This is the scientific notation way of doing this on your calculator. So that's the one that can kind of vex a lot of people, because like I said, there's a temptation to write something like I could go 5 10 to the 5th times 3, and that does work, but if it's backwards and it's a lot of extra key commands and something that's easy to screw up. So it does work if I do 10 to the 5th, 10 to the 5th times 3 does work. But this one right here is a little bit easier. So go 3. So let's do clear. 3 EE 5. Boom. 300,000. So Dylan, I just saw your post. So there's gonna be something along these lines. It's gonna be an exponential value. It may not look exactly like this. I can't remember what. Like I don't have Apple pulled up right now. I wish I had my regular calculator with me. I don't have my other calculator. My calculator. Let's see what it might show up as. It might show up as EXP. You might have to hit a shift sometimes. Like if you need to Google it, like whatever calculator you're using, and just Google it. Cool. All right. Let's get back to this here. Right. And so it may be written as not just EE, or you may have to hit a shift to get to it, to the EE. What calculator are you using right now? So you want so scientific is what you want for sure. And then you should be able to find some sort of EXP. Like are you on Windows or are you on Mac right now? Okay. Let me take a look. Yep. No, because the 10 with the X is the 10 to the X, but what we're looking for is the scientific notation version of it. So it does say EXP. Yeah. Does in that. So E is like it's this version of natural log. So these are like inverses of each other right here. So this is the natural log and E is the inverse of the natural log. So you don't want to use E. For this class, don't touch E. It's only going to cause confusion in this case. So don't use the E and don't use the LN right here. We're going to be using these two right here. So these two are inverses of one another, and these are the two that we're going to spend a lot of time with in this class right here. So E is the inverse of the natural log, and I don't want to go into. Well, actually, it's been so long. I'm really fuzzy on the natural log math, so I'm not going to go down that road. But because I don't even really recall how natural log works. It's been so long, so it's just not part of my vocabulary these days. Okay, cool. All right, so let's try this one. Whoa. 602 0000000. So this is why we start using. So in this case, this doesn't make a lot of sense to use scientific notation for 1,000. But when we start using these larger numbers, it makes a lot more sense. So if I'm going to go, so what I'm going to do right here is I'm going to go 1. So I can go 3, 6, 9, 12, 15, 18, 21, 22, 23. So what this is this 6.02 times 10 to the 23rd. Anybody know that number? What's that number? Yes, it's a mole. So it's a mole of atoms. If you work in chemistry, that number is, and I don't know why, like where that number actually even came from, but some standardized value. But it's like it's a quantity of atoms. So we can see in what's that? So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20, 21, 22, 23. Whoops. Let me get that. Correct. Yeah. So basically we're trying to get to this is what we call our significant digit. And in this case, what I did is I included 6.02. So I mean, I could write, if I really wanted to, I could write 602 times 10 to the 21st. So I could write 602 times 10 to the 21st. But usually we want to try to condense this down to like a single digit down here. So it's going to be 6.02 times 10 to the 23rd is this value. So now what happens if I have, say, a bunch of different values over here? Like maybe it was 6, I don't even know what that number is. Like that's so many zeros. I don't know if that's quadrillion or something like that. But maybe I have like a 0, 0. Maybe I have like a 1, 2 and a 5 right here at these values. Well, this number is so big compared to these numbers down here that these essentially fall off and they're not really that important. So we're essentially kind of rounding. But for a lot of what we're doing, this is like, if I go to, because a change in this number up here is much more significant than a change in this value number down here. So in other words, even if this is 602 000 156895435489624 I'll still round all of that off and go with this here because these numbers are so massive compared to these numbers down here that they're really they're insignificant. So that's why we call these like significant numbers, and these are the insignificant numbers. And we're lopping those off, and we're writing this as 6 times 10 to the 23rd. So what if we want to write 2? So how do we write that one in terms of scientific notation? So what we're going to do is we're going to write this as 2 times 10 to the 0. That doesn't make a lot of sense, but I mean, it does make sense. This is totally valid right here. What this says is that if we take a 10 to the 0, in fact, try it on your calculator, do 2EE10 0. Or actually, 2EE0. Let's do it. 2EE0 equals, and I get 2. So that one seems like a little bit kind of the wrong way to do it because, I mean, we're using more digits to represent this, but it's still worth understanding how this works. Okay, well, what about this one right here? Negative 53,000. So what we need to do is it's basically, we need to go how many values right here? It goes 1, 2, 3, 4. And you're like, well, what about this negative bit right here? Well, it turns out that negative stays right where it was. It's negative 5.3 times 10 to the 4th. That may be a bit of a brain teaser. Because you're like, well, wait a minute, what about decimal points? Well, negative and decimal points are two different things. So in this case, what we're doing is we're just still, how many decimal points do we need to move here to get to this point right here? But the negative still remains. So negative 5.3 times 10 to the 4th is negative 53,000. And again, like you may be going, wait, why am I doing this? Because this seems like this is just as many characters as this one is over here. In fact, this one looks cleaner than this one does over here. Why would I use this ever when I could use this one right here? It'll come clear when we start talking about human scale. It gets much more complicated. Our numbers, we tend to work on numbers like this when we talk about perception. These numbers are massive. So that tends to be a little bit more how we work with this stuff. All right, let's do another one. Point 2. See if you can, so do this for me right now. If you have a pencil and paper, write it down. See if you can write that the scientific notation version of that one down. There it is, 2 times 10 to the negative 1. Because in this case, we need to move the decimal point right. And therefore, we moved it, which implies a negative. We're moving that in the negative 1 direction right there. Cool. Now, I imagine some people are like, yep, I totally get this. And I imagine some of you out there are like, this is a little bit fuzzy. This is a little bit new, or I haven't seen this for a long time, and that's okay. By doing this over and over and over, practice it. Practice writing scientific notation numbers down. We're not like that is going to be part of one of the like a question that you're going to have to get comfortable converting between your decimal notation and your scientific notation. So practice just writing pull out some just random numbers, right? Just write down a random number and then write some scientific notation. If you get confused, go to YouTube. There's a bunch of videos on scientific notation description that'll give a lot more in-depth description than what I'm be able to cover in this class right now. But experiment with it. And once you get the hang of it, it makes a lot of sense. And to the point where in my world, I just don't even notice that I'm doing it. It's just scientific notation. It's just, I see these numbers as the same thing. Like I don't see any difference between the two of those. But in my world, I use that a lot. I use these numbers a lot. So I completely sympathize if you don't see this stuff very often, that can be a problem. Cool. All right. Try to beat me to it. See if you can write this one in scientific notation. So it's 0.0. So there's 4 zeros, 4 5. Try and beat me to the answer on this one. Whoops. What happened there? All right, let's take a look at the answer. 4.5 times 10 to the negative 5. So these two are really useful. So what we're going to see is that, again, the reason we use scientific notation is to express very large or very small numbers with a condensed format right here. All right. Oh, I have one more of them here, I guess. Okay, this one's harder to read, so I'm going to count them out for you. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 decimal points to move across there. Write that one out. Yeah, I see some people getting it in there. 1 times 10 to the negative 12. This one's an important one. We're going to see this one. You're going to get real annoyed by this number right here because we're going to use this one a lot. This is a special number right here. All right, my friends, let's do this. We're going to jump down now over and do some clicker questions. So let's give this a shot. So what we're going to do here, don't write this. Please don't write it in the chat. Don't write the answer down. Because we want to do this as we're gonna build some chops here. So which of the following represents 7.554 times 10 to the negative 4? So what we're gonna do is we're gonna go to breakout rooms right here. And I'm gonna start this. So like, what I'm gonna do is I'm gonna start my clicker so you can see how this thing works. So I'm gonna start the class. I'll show the answer. I'll show that thing again here, but I want you to be able to see what I'm looking at here before we move on here. So I'm going to do a multiple choice question. Let's do this right. See, let's see. Okay. So at this point, you should be able to see on the class that it's going. And in fact, I can see that I have 37 people, 38, 39. Cool. So you can actually see yourself in this roster right now. But I want you to be able to see yourself first before we do this question. And then the way this is going to go is I'm going to do a multiple choice question. And what I'm going to do is we're going to do this one not doing the breakout rooms. We're going to do this one as a group together. And then we're going to do the breakout rooms following this one, just because I want to get everybody up to speed so you can see how this is going to work as a group right here. So I'm going to hit go. And right now you have the ability to answer this. So, cool. So now we're starting to see the responses come in. So I have 36 responses. I don't know how many people we have in the class right now logged in, but we should see this climbing up. So I'm going to pull this to my other screen for a moment so I can see. All right, where'd it go? Okay. Okay. So I have 62 responses, 63 responses so far. Let's pause for a minute. Well, I'm not going to pause. I'll keep this thing open. I'm going to leave this thing open right now. So a couple of tips here. You can change your answer as many times as you want. So if you want to if you click in an answer and you go, oh man, what's this? Like, what is this? And then you click off, you're like, oh, I want to change my mind. You can change your mind as often as you want, but please don't just be clicking back and forth. Like that's a bad strategy. But now if you're clicking back and forth, and then what you want to do is, well, okay, first off, are there remaining issues? Is anybody having problems logging in and seeing this right now? Okay. So, Holland, what's the snag? But you do see my class and you're logged into that one? No, it's on Clicker. It's on the clicker app. Okay. Yeah, but I can't do that. To get the points, you have to click into to the app. How about anybody else? Anyone else seeing it or having issues? Just clicker right now. I haven't closed it, so you won't be able to see the results yet. And also, when it does it, it should show you a picture of this screen, right? Is it showing you that? But it's not showing. It's not showing you my. Is it showing? Okay, is it showing my second screen or just my first screen? Okay. Okay, cool. Because yeah, you have to create. You have to create an account and use your UC Denver credentials. All right. So I see that I have 65 people clicked in right now, but there's some people that are, I don't know how many people we have in the class. We have 71 peeps in the class, he said, Lucero. So, okay. So that means we have a few people that are not clicking in, which probably means that they're just hitting go on the class. So this is why you need to stay tuned into the class to get those things. How you doing, Holland? You getting there closer? Okay, cool. All right. So what I'm going to do right now, even if you missed out on one, it's okay. So what I'm going to do is I'm going to close this one up and I'm going to expand this out. I'm going to hit stop. We're going to move a lot faster on these going forward, by the way. So we're trying to iron out the kinks in this case. So I hit stop and let's take a look. Nice. So we have 60 people answered E. We have 2 people answered A, 1 answered C, and 1 answered D. So I click on this. Bing, you got points for that. Yay. So the way this is supposed to work is that for every one of these, even if you answered the wrong answer, you still get a point. But if you answered the correct answer, you get 2 points. So it's worth clicking, even if you have to guess, even if you don't know, just guess. Don't not click. 0 is bad. At least you get some extra points for this. So what we're going to do though going forward is I want you to check with your peers to make sure that they're getting the same answer as you. And to do this, we're going to use the breakout rooms. And so what we're going to do is I'm going to go into the next one. So I'm going to close this up, close the poll, and I'm going to move on to the next question here. So the answer in case is indeed 0.0007445 because this is 7445 10 to the negative 4. So it goes 1, 2, 3. I'm sorry, my bad. 1, 2, 3, 4. So if I move the decimal point there, I moved it to the right 4 places to get 7.445 times 10 to the negative 4 is this one right here. All right, let's go the other direction. Let's do this. I'm going to go ahead and hit go on this one right here. And you can click in if you want to right now. But what I'm going to do is I'm going to push you into breakout rooms. And in this, I want you to, where is the breakout rooms tab thing? Breakout rooms. There it is. Okay. What I'm going to do is I'm going to have you go into breakout rooms and I want you to confirm with everybody around you that you guys all have the same answer. And if you don't have the same answer, there we go. Let's do this many breakout rooms. So what I'm going to do is I'm only going to give you like, a couple minutes on this one. So you'll have I'll give you a minute in there and then you're going to go to the breakout room, talk to your peers, go, did you guys get this? Did you guys get this? And make sure that everyone in your group has the same answer before you leave the room. And then when you're done with that, you can either come back or I'm going to hit at 60 seconds. I'm going to tell you that I'm going to force you to come back. So let's try this right here. Sign automatically and go for it. Is it started? Open all rooms. Go. All right, there you go. Now it's going. All right, wait, everybody come back in here. I don't know if anybody, I can't tell from my perspective how many people are still need to come back. That's okay. I'll hit the return button a little quicker. Okay. My problem is I can't see that. Well, I guess I can kind of see it. It's hidden. I have to hover to see that one. Okay, I can kind of see the breakout rooms thing. All right. So let's close this one out and the answer. Oops. Let's do. Yay. So everybody got it. That's exactly what we want to see. 63, 100% got C right there. So beautiful. What you got? So that's a good, great question. So yes, it can be 5.92382. But as we kind of mentioned before, these become less significant. So these are the really important ones up here, and these ones are less significant. So we just lop those off. We round up to the nearest one over here. So if, depending on what case you're talking about, like it may be that that you could write at 5.92382 times 10 to the fifth, but there's no real advantage to that because obviously we already wrote the whole thing out and times 10 to the fifth. And so there's no advantage to doing that. So what this does is implies that these values, well, I mean, they're not very significant. They're least significant values. So basically these numbers, because if I change this one to the difference between 592,382 and the difference between 592,383, that's such a small change that like it really doesn't make a difference for what we're actually talking about in practical purposes. So we can lop all this stuff off here. So you could write that out like if you wanted to, but and depending on your situation, it may be that that's important to you for the calculation. But generally speaking, it's usually going to be like one digit here, 5 point, and then usually it's going to be like one or two of these values right here, and then the rest usually get lopped off. So it could be you could even go so far as to say 6 times 10 to the fifth. And that's a pretty bold rounding because this is a pretty significant value, but these are becoming less significant as I go down here. Good question though. Thank you. Okay, let's do it again. Oh, okay. So now what we want to do is we want to move on. So we got to keep things moving along here. So as we build this process in, get used to this concept, and we're gonna be doing this a little bit quicker. So I will say though, just as a quick feedback thing though, did going into group did your breakout room help you get the answer? Cool. I think what it's going to do is for the day, it's going to be the same one just because I want you guys to get to know each other. So if you get this done, like if you go into the group, into the group room, you're like, hey, did you guys get C? Yep, we're all good. And if you get that, then go, hey, cool. I'm so-and-so. I'm from here. This is what I do. Go ahead and talk for a minute and just get to know each other. Cause I want you to get to know each other a little bit more. I mean, you guys are talking through the chat and also maybe on Discord, but I want you to be able to see each other and talk. And if you want to turn your cameras on, get to know each other. Cause this is a great way how we can say, what's up? So when we get back on real life, you can say yo, I remember you. But also it could be that if you go into the thing, you maybe two of you are like, yeah, I totally get this. And the two of you are like, I have no idea what the hell is going on here. Can somebody explain this to me? This is so confusing. And it's up for other people to help out. If you understand this stuff and you go into the room, go, hey, oh yeah, I can really help out with this. I believe you can screen share in the room. So if you want to show people how you do your stuff, like if you want to hold up a piece of paper or something like that, the math is hard to show on screen, but you can talk to each other and walk each other through this stuff. So help each other out because I know I speak fast. I apologize, but I want you to give you the time to communicate with each other because I'm sitting there, I got my little blinders on and I teach you my way, but there's a lot better ways. And I'll tell you what, one of the best ways to learn something is to teach it. So helping each other out and teaching each other is a great way to talk about this stuff. Cool. Let's move on a little bit. So next we want to talk about this concept of logarithms. So logarithms are another way. We want to add this notion of how we talk about scale. So to do this, we need a different way of looking at these kind of numbers. So this is another kind of calculator trick right here. So what I want you to do with your calculator is I want you to take the log value of 1. And to do this, so I'm going to take the log value of 1, 10, 2, and you can see the values are right here to confirm. But the way you do this on your calculator is going to be going to, where'd my calculator go? Oh, I lost it. I closed it. And it moved over here. So what I want to do is I take the log value of 1, I hit 1, and I hit log. In this case, I'm doing log base 10. This is kind of, this one's a very specific. What's up? Oh, what are you seeing on my... Okay. Yeah, I don't know. Maybe it was just a little synchronization issue. So like it was maybe internet issue or something there. All right. So to do this, I'm going to hit clear. And so if I want to take a logarithm of a value, I'm going to hit 1 and hit log base 10. So I hit 10 and I get 0. That's kind of boring. So I'm going to clear this out. I'm going to hit 10 and hit log base 10. 1. Hit that. Hit 100. Log base 10. 2. So I want you to do that on your own calculator just to confirm that what you get, these values right here, are indeed happening. Cool. ln is not the run. That's the natural log. So we don't want ln. ln is a different version of it. It's a different base value. So what we want is log 10. So actually find the log button on your calculator. And maybe you have to hit shift to get to those other values. I don't know if I can, this one does shift. Oh yeah, if I hit second right here, you'll see that these values change a little bit. So sometimes the calculator has a shift, sometimes this one has a second. But in this case, I just have to do that one right there. But mine shows up right here as a log on the basic Apple one. So, yeah, go ahead. Yep. So and it depends on if you're using like, you know, what they call like reverse Polish or some of these other, the way you enter in some side, like the fancier scientific calculators, you would do like log 0 enter. But my scientific calculator is just like a $5 one from Office Depot. I go 0 log and that's it. I don't have to do anything else. So you may have to, if yours has an enter, you might do log 0 enter or maybe 0 log, and that's all mine does. So it depends on the order how you enter it on your calculator. Not every calculator, but there's different styles of calculators. Did you get it? Oh, sure. Okay, so you're starting to see a trend right here, right? So what would you see a log of 1,000,000 is? 6, right? Okay, let's do a question. Let's get some points. What's the log value of this? So let's start this up. Multiple choice, go. I'm going to throw you into a room and confirm the value with everybody else. So it's 10 million. Just go double check with everybody. Oh, I did it already? Okay. Shit. I don't know how to cancel out of that. Like, basically I was trying to make this one a really short one, but it says close all breakout rooms, close in 39 seconds. All right. Well, we'll just have to do this one as a group. Sorry. So you should probably be able to do this one. You can do this one without a calculator. Of course, double check yourself with a calculator, but try it without a calculator first. All right, so we're all back. Let's take a look. All right, friends. Since we didn't get to go in there, yell it out. What's the answer? 7. All right. So I still have it open. If you didn't choose 7, change your number. Last call. Cool. Yay. Everybody gets points there. In my other classes, so I'll have you all for next semester, and some of I've had you before in my critical listening class. If you get the whole thing right, we get what's called the ding of joy. It means you get we'll get a ding when the whole class gets it right. But that's awesome. Nice job. Okay, let's move on. All right, here we go again. Go. What's the log value of 1 times 10 to the 8th? Ah. Get to those breakout rooms. Try typing this in. So 1 EE8 log value of that. Go double check with everybody. Ask each other for help. All right, we're back. Stop that. And the answer is, wait, where's that one? Yay. 8. Cool. See a shortcut there? So we can start to see that these exponential and log values, there's a pretty interesting relationship. So that log value is that value up there. Interesting. All right, let's do another one. Yep. So I go 1 EE8 equals log. Enter. Oh, sorry. I guess. So I go 1 times 10 to the 8th. So I say, this is me saying times 10 to the 1 times 10 to the 8th equals that value right there. And I take the log of that value and I get 8. Does that make sense? Yeah. Cool. All right. What's the log of 2? So just go in. Let's jump into your rooms, try it real quick, and we'll call back. We'll come back and call it good. Sorry. Like we'll bust out here like right after this done. I've got 34 seconds for everybody to get back in, and we'll get the answer and we'll call a class there. But I just need to pull everybody back in for just one moment here once we get that once that gets closed. It's kind of a balance between how long I get people get into the room and when I hit the close rooms for 60 seconds, because I don't feel like we need more than 2 minutes for these really fast ones. Yeah. No. Is times is 10 to the is exponential value. So it's not log. So log is log, and then the EE is times 10 to the. So basically, if I was going to write, so in this case, like if I want to get the value of this one, I just hit 2 and then hit the log button, and that'll give you the value. Of the, you sure you didn't do 20? Okay, here, let's go ahead and stop this out, and then we'll call it good.